I'm Anil Kumar, and in this particular video, we'll prove trigonometric identities. I'm starting with very simple identities. We have two here, and both have the same strategy. The idea is to write tan x as ratio of sine and cosine, and then prove the identity. The two identities are sine x divided by tan x is cosine x, and 1 minus cos square x is equals to sine x cosine x tan x. So let's begin with the very first one. As I was saying, you could always say, what is tan x? You know, tan x is sine x divided by cosine x. And that is what we are going to use to prove the identity. So let's begin with the left side. Always begin from one side. So left side is sine x divided by tan x. Now you can write tan x as ratio of sine and cosine. So it could be written as, you could also, better write this as sine x times 1 over tan x. That helps. If you write like this, it becomes kind of more clear. So we can write this as sine x times. Now tan x is sine x over cos x. Tan x is in the denominator. So you can write this like sine x over cos x. I do not want you to write 1 over sine x over cos x. Avoid 3 layers of fractions. That is my whole idea here, right? So write as I have written. So 1 over tan x should be written as cos over sine x, or you could write sine first and then cos. Now you can simplify and you get this as equals to cosine x, which is equals to the right side. So once you prove left side is right side, both are equal, that means the identity has been proven. Now let's do the second one, which is 1 minus cos square x equals to sine x cosine x tan x. Now sometimes we may do both sides. So 1 minus cos square x, as you can see here, is actually equals to sine square x. Now here we have used the Pythagorean identity, which says sine square x plus cos square x is equals to 1. So 1 minus cos square x is sine square x. So the left side is sine square x. On the right side, what we have sine x, cos x, and tan x. For tan x, I'll write this as sine x over cosine x, correct? So as soon as you write sine x over cosine x, you can simplify very easily, right? So this is the right side. So it gives us sine square x. Do you see that? Sine square x. Well, if you don't start from the left side and right side both, and if you have to do only from one side, you can always write sine square x as 1 minus cos square x, and then say that is equals to the left side. Is it okay? So you could follow these steps starting from left side and also come to right side. Or at times you can do both halfway kind of, right, and prove that they are both sine square x. So all these alternatives are possible to prove identities. Some teachers, however, prefer that you start from one side and prove that is equal to the other side. So in this case we started from the right side and we could prove right side as left side. As you can see, very simple. We just wrote tan x as sine over cosine and got both these identities. So these are two basic strategies which will be used. Using sine square x plus cos square x equals to 1 and tan x effectively, you can prove most of the identities. Thank you.